Hello guys, welcome to calculus class. This time I'm gonna go over a non-calculator portion of 2025 version. So this one is really easy. I love non-calculator session because there's no such thing as like trick. It's straightforward. So here, table. Keep that in mind. As soon as you see table, you're gonna either see slope and Riemann sum. Okay. Approximate r prime of 1. Okay, using the average rate of change, which is a slope, on interval 0 to 2, show the work that leads to your answer. Indicate unit in measure. So only thing that you have to really be careful is the unit. So out of t is the words per minute already. So when you find the slope, it's going to be per minute per minute. 1 is between here and here. So when you have to do it, just make sure you write down r prime of 1. It's going to be approximately, you're going to write down, what's it called? How do we set up? R of 2 minus R of, I don't think you have to write this one down, but I'm just writing this one down for you. Which is R of 2 is going to be 100 minus 90 over 2 minus 0, which is going to be 100 minus 90 is going to be 10. 2 minus is this, so it's going to be 5 words per minute, or you can write per minute squared, whichever makes you happy. Okay, so that's the 2 points question. I'm pretty sure setup is the 1 point, the answer is the 1 point. So B. Yeah, I will probably write only this portion with this. Okay, I will probably skip this one. Must there be the value of C? Okay, such that R of C is going to be 155. So this one is an intermediate value theorem because you're not looking for the slope. So are we going to have a 155? So here, 155 is going to be between these two, right? Only thing that we have to check is if it's continuous. And continuous reading for next. So students start reading a book at time equals 0. And continuous reading for next 10 minutes. And this is the speed of their reading. So yeah, it's continuous. So is that going to be there? Yeah. What you have to do is, let's see, between 0 and 10, right? So you have to write R of 0 is equal to 90. And you have to write R of 10 is equal to 162. Right? And R of C, which what we're going to do is a 155, right? So only thing that you have to do is 90, 155, 162. So therefore, only thing that what matters is this. Therefore, by intermediate value theorem, there must be a value C between 0 C, what was the domain? 10, such that R of C is equal to 155. Okay, now this is not gonna work if this number is above here. For example, if it was 170, there's no guarantee. Also, if it's not continuous, it's not guaranteed. Okay, it only works if it's continuous. All right, so let's do C now. Use trapezoidal to sum to subinterval to approximate this. So keep that in mind. When you do this, your 1 point is simply just indicating that. So 0 to 10, if you don't know forgot about the trapezoidal, just at least write this one down. How many subintervals is that? 3 subintervals. Yeah, so here to here, it's gonna be 2. Here to here is a 6. Here to here is another 2. And trapezoid, we gotta use both. Keep that in mind. Trapezoid is a B1 plus B2 times by height divided by 2. So it's gonna be B1. So I'm gonna put 90 plus 100 times 2 divided by 2 plus 100 plus 150 times 6 over 2 plus 150 plus 162 times 2 over 2. Yeah, so that's it. Do we have to simplify this? In order to get it, at least you have to, what's it called, simplify at least a little bit. But because according to the scoring point, I have to do the minimum, what's it called, minimum calculation. Yeah, that's the minimum calculation. What's that? 90 plus 100? It's gonna be 190. And looks like these two disappear, so I don't care. Plus 150 plus 50 is gonna be what? 250 times this one. When you cancel, it's gonna be times 3. So you can do it like this. Plus, it's 162. 150 times 162 is gonna be 312. I hope you guys, and 2 disappear. So if you leave it like this, that's fine. You still get the answer. But can you add them up? Yeah, if you want to, go ahead. 750 plus 312. When you combine them all, it's gonna be 1,252, something like that, I think. Yes, 1,000. Yeah. But if I were you, I would just leave it like this. That's totally fine. The minimum requirement is that you just adding this one up. You don't even have to do this portion. Still, you get full credit. All right. But if I were you, I will do until here. That's it. So let's do the D. So easy. I love table because you cannot go wrong. A teacher also sets reading at time equals 0 and continues reading for the next 10 minutes. The area which the teacher reads the modeled by this one. Okay, so this one is already the rate. Where WT is measured in words per minute, right? It's already the rate. Based on the model, how many words has the teacher read by the end of 10 minutes? Okay, so it's antiderivative because you want to know total amount, not the rate. So from 0 to, oh freak, it's non-calculator. So we actually have to calculate this without calculator, which is piece of cake. Again, you don't have to simplify everything, so keep that in mind. So let's do this. Antiderivative, so plus 1. So let's give negative 3 over 10 t to the third power, divide by 3, but that's too much, so I'm gonna just do multiply by, flip it. Instead of divide by 3, I'm gonna put 1/3. Plus, 1 plus 1 is gonna be 2, so it's 8t squared over 2 plus 100t from 10 to 0 to 10. Yep, so let's figure out. If you don't know what I did right here, you can just simply divide by 3. Do you see that divide 3 by 1? So you can still do it. Negative 3, keep that in mind. Outside is what? Goes to the top, negative 3 over 10 times 3 is 30. T to the third power plus this is gonna be 4. 4t squared plus 100t. Yeah, anyways, this one is gonna be 1 over 10. Negative 1 over 10. So let's plug it in. Negative 1 over 10, 10 to the third power plus 4, 10 squared plus 100, 10 minus, make sure you put big parentheses, negative 1 over 10, 0 to the third power. Do not assume everything's going to return to 0 because sometimes they don't. 100, but this one does. Yeah. So as you can see, this whole thing becomes 0, right? So your answer is going to be only this portion. Do I have to simplify everything? I don't have to because if I were you, I'll just let grader do it. But if you simplify everything, it's gonna be 1300, which, yeah, but answer wise, I will just leave it like this, okay? So that's it. Question number 3 is that easy. Oh, graph, which looks very easy. Let's do this. Graph number 4. G of x, okay, so the continuous function f is defined the closed intercept from here to here, considering 2 semicircle line segment. Okay, find g prime of 8. So here, let's see. g of x is equal to antiderivative of 6 to x f of t dt. And looks like this graph is a f. So you want to find g prime of 8, which means derivative and antiderivative onto each other. So it's going to be f of 8 times derivative of this, which is 1. But I don't care. Right, so let's find f of 8. F of 8, again, we want to find f of 8, which means right here, it's not the prime, so we want to find y value, which is 1. So it's going to be g prime of 8 is equal to 1. And that's it. I mean, that's a 2 point. Okay, it's a A. Let's do B. Find all value of x from ultimate -6 to 12, at which graph has the point of inflection. So point of inflection, G or F? G, right? Where G double prime is equal to 0. That's the inflection point. So what I have to do is I have to take derivative of this one twice. So let's do this. We already know g prime of x is equal to derivative of this, which is f prime of x. F of x. Because derivative and antiderivative onto each other. So you just put this one here times by 1 here. Now g double prime of x is f prime of x. So you want to know when f prime of x equal to 0 is the inflection point. So let's see. Right here, this is a 0 slope, and this is a 0 slope. So you can say f has 0 slope at is that x value or t value? X value. X equals -3 and x equals 3. Do you see -3 and 3? Yeah, that's only 0 slopes that we have. So I hope this one makes sense because it's so easy. Wait a second. Oh, never mind. It's not inflection point. Inflection point happens when f prime, what's it called? Never mind. Wait, I made a mistake. It's not the inflection. Inflection point happens. Oh, my mistake. Inflection point happens when like when the graph like changes like this, like that. All right. So when this double prime happens, when this one changes, when f switches positive slope to negative slope, that's when you do it. Because, yeah. So in this particular case, the graph of G has the point of inflection at where G double prime and f prime changes sign. So when does the slope changes a sign? So here. So when this changes sign, that's an inflection point, which, yeah. So let's say, so graph G has also point of inflection at what? Actually, this one has a lot. Here we go. Yep, so where x equals -3, I mean, that's good. And as I said, x equals 3, I was right here. Only thing that I didn't really pick up was right here. Because here, do you see this one changes negative to positive here? Wait, can I just get the, yeah, here. Do you see negative to positive? So it's gonna, at this point, so that's the inflection point. This is still positive slope. This is still positive slope. But do you see this positive slope changes to negative slope? So that's another inflection point. And this negative slope suddenly changes to positive slope right here. So where x equals 6, that is also, what's that called? Inflection point. So that's it. We got like these 3 points. Just like this, sometimes I make mistake. Actually, I make mistake very often, if you insist. Yeah, so what? Everyone learns by mistake. So keep that in mind here. I made a mistake because inflection point, I just naturally comes inflection point is that like G double prime is equal to 0 because that's normally where you find inflection point. But no, inflection point specifically means when J here and when this one switches a sign, like positive to negative. Okay, because sometimes when you have a graph, you're gonna have like just positive to positive. That's why it's not only this two, you also have this one as well. Like, yeah. All right, so we also have to consider that, but that one was like positive to positive, so that's why that was not an inflection point. Anyways, if you need more details, I'll explain it later. But right now, let's focus on the other one. Let's find G of 12 and G of 0 and label your answer. So you actually have to label your answer in right here. So let's do this. Oh, no, never mind. So here, G of x, I'm just copying this one down again. 6 to x f of t dt. Now, G of 12 is 0 to 12 f of t dt. Basically, you just want to find, because this one is just already f, when you take antiderivative, that's going to be area under the curve from, oh, it's not 0, it's a 6 to 12. So area under the curve, 6 to 12. What's the area? It's a triangle. 1, 2, 3, 4, 5, 6. 1, 2, 3. So it's going to be 1/2 base times height, which is going to 6 times 3 is 18 over 2, which is 9. Yep, that's it. This one, I don't think you necessarily have to write down the what's it called thing, so you're good. Now, if you want to find G of 0, that becomes 0 to 6 f of t dt. Yes, I cannot really tell the difference. I'm going to put 0 and 6 clearly here. Again, this one cannot be happening, so it's going to be negative 0 to 6 f of t dt. Keep that in mind. Always lower number on the left, higher number on the right. That's why I switched it with a negative. 0 to 6. This one. So I just have to find area of this semicircle and just put negative. If it was this one, negative has negative become positive, but this is positive side, so we're good. Let's do this. What's the radius? 1, 2, 3. So it's and half, right? So it's gonna be same thing as negative pi r squared over 2, which is negative 9 pi over 2. Yep, that's it. Now let's do D. Find the value of x which G attains the absolute minimum. Oh. Okay, so when they obtain absolute minimum. Okay, so absolute minimum. Whoa. Maximum or minimum happens when G prime goes, is it maximum minimum goes what? Negative to positive. That's the minimum, right? But it says absolute. So things are gonna be slightly different because we have to do, if it's just relative minimum, that's it. But if it's absolute, we actually have to find the absolutely like lowest number. So let's do this. G prime of x is equal to, you just take a derivative of this, which is f of x. F of x. And when they are equal to 0. So, let's see. When they're equal to 0, here. And then we also have to figure out these two numbers. Well, let's do this. So we have to find f of negative 6, and then f of 0, and f of 6. And f of negative 6 we already put here, so we only have to add f of 12. So what's f of negative 6? It's a 0, because again, only thing that we are doing is the area under the curve, because you just want to know when 1 prime is equal to 0. F of 0, we all, no, actually, yeah, area under the curve. So oh yes, I mean, yeah, whatever. F of, actually, it's, I think it's better to for me to write the G, because you actually have to plug in the original value. That's right, not here. So because here, because you want to find the original, you actually have to find the plug back into original function. But this time we don't have a function, we have a graph, so we are just trying to figure this one out into the graph. So after you find this like numbers here, we are just plugging this one in. So here, area under the curve from -6 to 0 is gonna be negative 9 pi over 2. Why? How do we know? We already got it from here. Do you see g of 0 here? It's gonna be negative pi over 2. Now g of 6. Here to here, now this is semicircle, so here to here is a negative 9 pi over 2, and here to here is positive 9 pi over 2. So this plus this will become 0. So it's going to be 0. And here to here, well, we already got this, which is going to be 9. So it's going to be 9. Now, if question was asking for the maximum, this is the absolute max, but we are looking for the absolute minimum. So it's going to be right here. That's the lowest value. So what you can do is, what's it called? So because this is the lowest point on the interval -6, x, 12, g attains an absolute minimum at x equals 0. All right. Yeah, only thing that could be really confusing was that, keep that in mind, g prime of x equals f of x equals 0. So, which I wrote down here. That's where this one is equal to 0. So that's, first you have to find where this one is equal to 0. And then you have to go plug it back to the original function if they have an equation. If not, then you just find area under the curve, which is this one. Do you see? G of x is this. That's why I'm just plugging these numbers in. I'm just putting like -6, like 0, 6, which is just simply area under the curve. All right, so, oh, that's it. So that's easy one. By the way, if few people ask me like, want me to do it again, I will, because I believe this video was not as smooth as I expected. But just at this moment, I'm too lazy to re-record because it's already 11:44 on Sunday. But because I love you guys, I'll make more accurate video if you guys request. All right, if 3 or more students request. Love you guys. Bye.